Hello my friends, welcome to your channel. This is World of the Technology Descriptions. My name is Maziar and I'm a mechanical designer. On this video I want to show you how I made a simple type of the Planetary Gearbox with FDM 3D printer. If you desire to see more, please subscribe my channel and like my video. I appreciate you and thank you for your watching. Let's go to see that. This is the first step. On this section I bring all of the segments to assemble together. First of all, I want to say that I suppose an approximate dimension of my gearbox, and based on that I make calculation for my gears on gear software such as Keysoft. I make accurate calculation based on my approximate dimension and provide CAD file of the gears. Fortunately, I can obtain a CAD file of the gears based on accurate calculation in gear software. Here you can see how I assemble the stage with the gear. This stage consists of sun gear, planet gears, and carrier part. Carrier part holds sun and planets, and all of these systems are rotating inside the internal gear. Sun stage is rotating, and the rotation of the sun stage provides rotating of the planets, and planets are rotating inside the internal gear, and this procedure provides rotating of the carrier part. This is the second stage, and I stick output shaft to carrier part. Rotating of the carrier part provides ratio of the stage, and I do this procedure for another stage. If you want to calculate the ratio of the gearbox, you must count number of the teeth of internal gear and divide it to number of the teeth of sun gear and add number 1. I do this procedure for every stage and multiply every stage ratio together to achieve a final ratio of the gearbox. At this section, I assemble internal gear together to avoid making support part during printing procedure. I adjust first stage to second stage and align both of them together. And put this collection inside the internal gear. This is the main basement. I divide it to two parts to avoid making support part on printing procedure to achieve a strong texture and suitable quality of the surface. It goes without saying that I don't focus on all of the principle for my design. Just I want to make a simple type of the planetary gearbox. I don't focus on main principle. For example, I don't use bearing and don't insert lubrication guide for gears and other parts. I assemble the cover to basement and adjust the whole together. On this section, I want to say that most of the designers tend to use previous calculation of the planetary states, because new calculation sometimes provides some problem on assembling procedure on manufacture process. Some of the new calculation provide more vibration and noise, and some of the designers tend to use a previous calculation. You can see this is a simple type of the coupling. It is designed based on flexible coupling, but I don't use a flexible segment between the teeth. I adjust the hole together and make them align. Most of the segments have some solution to align together, such as cover and electromotor flange. Based on the holes dimension, I choose bolt and nut. Previously, I mentioned that I avoid to focus on all of the function, but I consider some of the simple principle on my design. For example, I put a gap between the gears and carrier part to decrease friction between gears and segments. If you approve this video, please subscribe my channel and like my video. This work encourage me to share more video. Thank you so much. This is second step. On this stage, I convert CAD file to STL file to make G-code file from my segments. I choose suitable position for my segments to put on the table of my 3D printer. This issue is very important because I can choose that how 3D printer have to make support part on my segments. I avoid to make support parts because this problem provide weak texture on my segments and make deviation on the dimension. You can see how I make the segments part by part with 3D printer. I focus on all of the limitation during printing procedure and some of the problem during assembling of the segments. Let's go to see some of the moment of my printing. Enjoy that. Thanks for your watching. Please subscribe my channel and like this video to encourage me to share more. This is the third stage and I want to assemble all of the segments together. This is output cover, input cover, basement, internal gear, first stage, second stage, electromotor flange, and coupling. When I rotate sun is rotating, and planets are driven by the sun. And this procedure provides rotating of the carrier part. And when the carrier part is rotating inside the internal gear, this procedure provides a ratio of this stage, and I transfer this ratio to second stage. I put some of the second stage inside the carrier part of the first stage. And similar, the first stage, I put second stage inside the internal gear, like this. I stick output shaft to carrier part of the second stage because my gearbox consists of 2 stages. So I assemble the internal gear together. Because I use FDM printer and I avoid to make support part during printing procedure, so I print every internal gear and assemble both of them together. I adjust this hole and put something to avoid rotating internal gear of the first stage inside the major hole. When I rotate carrier part of the first stage, sun gear of the second stage is rotating. So I put the stages inside the internal gear. During my design, I don't focus on all of the details and the principle for designing a planetary gearbox. I want to make a simple type of the sun stage gears. This is input cover, and I have a guide, and I can put this collection inside this guide. And this solution provides alignments of all of the segments. This is the basement. I have a guide, and I can put the collection inside the guide to align all of the outer segments together. This is output cover, and furthermore I have another guide to align output cover with internal gear and output shaft. I adjust the hole and put the bolt inside the hole. This is electromotor, and I have coupling. Coupling make connection between electromotor and input shaft. I connect one segment of the coupling on electromotor shaft and another one on input shaft. This system similar to flexible coupling. Okay, everything is good. So I plug electricity to electromotor to show you how this is working. I will be back very soon, and I hope I can make more interesting videos like this. If you tend to see more, please subscribe my channel and like this video, and click on the bell.